Welcome back to the deep dive. Today we're going on a journey, a journey that goes back millions of years. We're looking at human biology to ask a really fundamental question.
Which is?
Why are the average male and female bodies built so differently? I mean, structurally.
Right.
Okay, so let's unpack this with some of the facts right from the research. On average, men have something like 60 to 75% more total muscle mass than women.
Which is a huge difference.
It's massive.
Yeah.
But then you flip it, and women carry about 1.6 times the body fat percentage, and it's stored differently. So this deep dive is all about the biology, the evolutionary history behind this. It's not about value, but about the deep, deep history that created these two blueprints.
That's the perfect word for it, blueprints. What we're talking about is called sexual dimorphism. It's just those predictable physical differences that go beyond the reproductive organs themselves.
And the fascinating part is the why, right?
Exactly. Why did this divergence happen? These differences are essentially, they're like fossilized evidence of two completely different reproductive strategies. Each one was optimizing for a totally different goal over millions of years.
So our mission today is to connect that ultimate cause, the evolutionary pressure.
To the proximate cause, which is the hormonal machinery inside us that actually does the building.
Okay, let's start with the female strategy, though. The sources all point to one defining factor: massive biological commitment. We're talking about incredibly high parental investment.
It's the sheer caloric cost: pregnancy, birth, and then lactation. Ancestrally, that could last 2, 3, even 4 years for just one child.
That's the ultimate constraint, then.
It is. For an ancestral female, the main challenge wasn't always finding a mate. It was keeping herself and her offspring alive, which was all about physiology and, crucially, energy.
So natural selection favored.
All the way.
Metabolic efficiency.
Efficiency and energy conservation, absolutely. The female body was basically built to be a reliable long-distance engine.
Okay, but this is the part I find a little counterintuitive. Why not just favor maximum strength? You know, for defense or carrying things. The research talks about this expensive tissue hypothesis, which almost makes muscle sound like a bad thing.
That's such a good question because it gets right to the heart of the trade-off.
Right.
Yes, muscle gives you strength, but it is incredibly expensive, metabolically speaking. Even when you're just sitting there, it's burning calories.
About 50 calories per kilogram a day, I think.
Around that, yeah. Now, for an ancestral woman facing, say, a drought or a long winter, maintaining a huge amount of that expensive muscle, that was risk.
A risk of burning calories that you need
for the fetus. Or for producing milk.
Oh.
Evolution's math basically said the risk of not having enough energy to sustain a baby outweighs the benefit of having a bit more upper body strength. So reproductive reliability won out.
So the body chose insurance over immediate power. It didn't maximize muscle. It maximized specialized fat storage. That was the insurance policy.
Precisely. We see women with higher body fat percentages, around 25 to 31% versus 15 to 20% in men. But the key is where that fat is.
The hips and thighs. The glutefemoral depots.
And this isn't just generic energy, it's a specialized reserve. It acts like a dedicated supply chain.
Tell me more about that. Why there, specifically?
Because that fat is loaded with specific fatty acids, things like DHA.
Which is critical for brain development.
Fetal brain development, exactly. It's essential. And the body is smart. It stores these key nutrients in the lower body, and then during late pregnancy and lactation, it mobilizes that fat preferentially. It breaks it down to send those building blocks right to the baby's brain.
That is just incredible. And the sources show that these specific reserves actually go down with each child you have.
It's direct proof of consumption, yes. And that also helps explain the classic pear-shaped distribution.
It also frees up abdominal space, right?
It does. It's this incredibly integrated system, all tailored for high-investment childbearing.
So, to zoom out, the female strategy is all about metabolic efficiency and reliable storage. And this is even baked into the metabolism itself.
Yes. If you adjust for body composition, women still have a slightly lower basal metabolic rate, maybe 3 to 10% lower.
It doesn't sound like a lot.
Day to day, no. But over weeks of scarcity, that small, consistent energy saving could be the difference between survival and failure. Every calorie saved was a win.
Okay, so that's one side of the coin, right? The female body is optimizing for energy conservation.
Right, reliability.
But now we have to flip it, because For the male strategy, it's not about conservation at all, is it? The limiting pressure was something else entirely.
Not in the slightest. It was about gaining access to the product of all that female efficiency. It was about access to mates, and that drove a whole different process, sexual selection.
This is where the divergence just explodes.
It really does. Sperm is metabolically cheap, so a successful male could, potentially father many, many offspring. This created huge variance in reproductive success.
A high-risk, high-reward physiology.
Exactly. If you were stronger, faster, more intimidating than the other guys, the genetic payoff was enormous.
And that payoff came through physical contests. The sources talk about intense competition males, wrestling, grappling, defending resources. All of it required raw strength.
And that selective pressure is what drove the evolution of larger skeletal frames, denser bones, and way more muscle mass, especially in the upper body.
I think I saw a stat that men have something like 72% more muscle in their arms.
That's right, which is a perfect adaptation for fighting, for throwing projectiles, for everything involved in that kind of contest competition.
But it's not just the muscle itself. It's also about signaling that you have that strength. A deterrent.
Absolutely. The cost of all that muscle was high, metabolically, but the reward winning a mate was higher. So we also see the evolution of traits that signal formidability.
Things like a bigger jaw, a more prominent brow ridge.
Broader shoulders, beards, a lower voice. These are all direct results of high testosterone exposure, and they all signal competitive ability.
So, muscularity and strength were direct predictors of mating success. More partners, more offspring. Men were evolutionarily built for power and for competition.
It was a feedback loop. The capacity for competition was selected for, and the signals that broadcast that capacity were also selected for. It maximized your odds of winning.
Okay, so we've got the ultimate cause. Two blueprints, one for efficiency, one for explosive strength. Now for the proximate cause, how does the body actually build these two different structures?
That's where the endocrine system comes in. The hormones are the chemical architects executing these evolutionary orders, especially during puberty.
And the main engine for the male blueprint is testosterone, the anabolic engine.
It's a massive surge. In boys, levels can rise 20 or 30 times, ending up about 15 times higher than in adult women.
And that just tells the body to build.
It stimulates protein synthesis, the growth of muscle fibers, especially those fast-twitch power fibers. And it's not just muscle. It promotes larger bones, a bigger heart, higher hemoglobin. It builds a body designed for intense physical exertion.
And there's a behavioral link, too, isn't there? It lowers the threshold for things like aggression and risk-taking.
Which reinforces those very contest behaviors that we're being selected for.
Now, on the other side, you have estrogen, the metabolic regulator.
Exactly. Estrogen actually signals for bone growth to stop sooner. That's one reason for the shorter average stature. But it also shapes the skeleton.
Also,
While testosterone builds broad shoulders, estrogen helps create a wider, more rounded pelvis.
a direct adaptation for childbirth.
Obvious, but critical. And estrogen is absolutely central to fat distribution. It directs fat to those specialized subcutaneous depots, the hips and thighs, while limiting the risky visceral fat around the organs.
And it also fine-tunes the metabolism, right?
It does, and makes the female body a bit more efficient at burning fat for fuel during endurance tasks, which, again, supports that whole energy conservation strategy.
So the synthesis is pretty clear. Testosterone drives muscle and lean mass for power and competition. Estrogen regulates fat storage and skeletal changes for reproduction and efficiency.
And these are powerful trends in humans, and this is a really important point, this human pattern of the larger, stronger male is not some universal biological rule.
Right. Nature flips the script all the time.
Right.
The direction of dimorphism just depends on the species ecology.
A perfect example is the spotted hyena. The females are larger, stronger, more aggressive, and they're socially dominant.
Why?
Because in their matriarchal clans, females face intense competition for the resources they need to produce milk. This has led to them being exposed to much higher levels of androgens.
It really shows our species is just one data point, and then you have something really extreme, like the deep-sea anglerfish.
Truly bizarre. The female is massive, the male is tiny, and his only job is to find a female and basically fuse to her body. He becomes a permanent sperm donor.
So his entire evolutionary strategy is just find a mate. That's it.
That's it. His investment is almost zero compared to hers. Then you have things like spiders or praying mantises.
Where the female is much bigger.
Significantly. And that's about fecundity selection. A bigger body can simply hold more eggs. More eggs, more offspring. Simple as that.
So what all these examples show is that our specific pattern of dimorphism reflects our ancestral history. But the rules can be totally different for other species.
Exactly. Our history was one of male competition and high female investment. But that's just one successful strategy out of millions.
So let's bring this back home. The body you're in right now is basically the fossilized evidence of your ancestors' survival strategies. It was optimized for either energy efficiency or explosive strength.
And that leads to the crucial clarification. These are average differences. They're neutral biological outcomes from selection in the past. They are not moral judgments or prescriptions for modern life.
And individual variation is huge. The overlap is substantial.
It is. We carry this legacy, a body built for a world of scarcity and physical combat. But our modern world is, well, it's very different.
High-calorie food is everywhere, and many of us live sedentary lives. The very pressures that created these blueprints are, for many people, disappearing.
Which raises a really profound question for the future, doesn't it? If those ancient pressures are fading, what are the new pressures? What aspects of our modern world, mental stress, social dynamics, new nutritional environments, might slowly be reshaping these ancient blueprints for the generations to come?
That is definitely something for you to mull over on your own.